Okay, we need to go over completing the square again because, first of all, you've had a long break and you may not remember how to do this. And some of you did not even remember how to do it on your last test. So we're going to go over this so that you'll be ready when we come back on Tuesday and Wednesday to learn more about completing the square when you don't have a leading coefficient of 1. And I'll explain what that means. But in order to be ready for that, you need to remember how to do completing the square. All right. So when you solve a quadratic equation, this is a quadratic equation, meaning that the highest power on x is 2. You want to find out what values of x will make this equation true. That's called finding the solution of the equation, or the solutions of the equation. In this case, because a quadratic equation is always going to have 2 solutions. So the first thing we're going to do is get everything on one side. So we'll subtract 8 and add 8x on both sides so that we'll end up with x squared plus 8x minus 8 equals 0. And now what we want to do is move that 8, that negative 8 there, back to the other side, add 8 on both sides. And we're going to leave a blank here so that we can add something. We're putting this negative 8 on the right, so we're adding 8 on both sides, and then whatever we put in that blank on the left side, we're going to have to put in the blank on the right side because that's the only legal way to add something when you're dealing with an equation. So what are we going to put in that blank? What we're going to put in that blank is half the x coefficient squared. The x coefficient is just the number that you are multiplying x by, which in this case is 8. So what we're going to do is we're going to divide 8 by 2 to get 4, and then we're going to square that to get 16. So we're going to add 16 on both sides of this equation. When we do that, we have now created a perfect square trinomial. This trinomial can be written as a binomial squared. This was our whole reason for adding 16 on both sides. What we will get inside this parentheses, we will get x plus half the x coefficient, which is 8 over 2. So we're taking half the x coefficient. That's what goes here. And that is 4. So I'll just write 4. So that's the left side of the equation. That is how we can write that left side. And then on the right, 8 plus 16 is 24. All right, so now we're in a position where we can solve for x. We can take the square root on both sides of the equation. We'll take the square root over here, and we will take the square root over here, remembering that when you take the square root, you have to put plus or minus. The left side, when you take the square root of a perfect square, the square root and the square cancel out. So we would have x plus 4 is equal to plus or minus the square root of 24, and we can break that up into the square root of 4 times the square root of 6, because 4 times 6 is 24. So x plus 4 is equal to plus or minus the square root of 4 is 2, and the square root of 6 is irrational, and it cannot be simplified any further. Now we're going to get x completely by itself, and that will give us the solutions of the equation. We want to know what is x? What are the values that x could be? So if we subtract 4 on both sides, we're going to have x equals negative 4 plus or minus 2 times the square root of 6. So those are the solutions, and that is how you solve a quadratic equation by completing the square. Okay, let's look at another example. Solve by completing the square. Negative 5x minus 6 equals negative x squared. On this one, I want you to turn off the video and do this one on your own. And then when you're done and you think you have the right answer, go ahead and turn the video back on and see if you did it the right way. So hit pause and try this one on your own. Okay, let's see how you did. First of all, we're going to get everything on one side of the equation. All we have to do is add x squared to both sides. So we're going to have x squared minus 5x minus 6 equals 0. And now we're going to move this 6 to the other side. So we'll add 6 on both sides, and we'll leave a blank next to the 5x. So we're going to have 6 on the right plus something. All right, that number is always half the x coefficient squared. So our x coefficient is 5, so half of 5 is 5 halves. And now we're going to square that. And that is 25 fourths. So that is what we're going to add to both sides of the equation. All right, now we will write the left side of the equation as a perfect square binomial. We'll have an x here, and in this spot, we're going to have half the x coefficient. So minus, because it's negative, 5 over 2. That's half the x coefficient. On the right side, we're going to add 6 plus 25 fourths. We know that 6 is 24 fourths. And then if we add 25 fourths, we're going to have 49 fourths. Now we're going to take the square root on both sides. We will put a plus or a minus over here when we take that square root. On the left side, the square and the square root cancel each other out, so we have x minus 5 halves is equal to plus or minus the square root of 49 over the square root of 4. So x minus 5 halves is equal to plus or minus 7 halves. Now we're going to add 5 halves to both sides so that we can get x by itself. So x is equal to 5 halves plus or minus 7 halves. So the two solutions for x are going to be 5 halves plus 7 halves, which is 12 halves, which is 6. Or x could be 5 halves minus 7 halves, which is going to be negative 2 halves, which is negative 1. So those are the two solutions for x, 6 and negative 1. And if you go back to the original equation, you can plug those in to see that they work. So if we put in 6 for x, we're going to have negative 5 times 6 minus 6 equals the opposite of 6 squared. So that's negative 30 minus 6 is equal to negative 36. And that is true. So 6 works. If we put in negative 1, we're going to have negative 5 times negative 1 minus 6 is equal to the opposite of negative 1 squared. So that's going to be 5 minus 6 is equal to the opposite of 1, and that is true. So 6 and negative 1 are the solutions to that quadratic. And that is how you solve a quadratic by completing the square. Make sure that you know how to do this by the time you come back to class. There are more that you can practice in your book. Completing the square was lesson 50 if you want to look back at it. Okay, next of all, we need to go over the trig functions again because it seems like some of you had trouble with that on the test. So let's just go back and remember what the trig functions are. If you have a right triangle and you have some angle in that triangle, we'll call this angle theta. And suppose the sides of this triangle are A, B, and C, then we would say the sine of theta, this angle, is equal to the opposite side to theta divided by the hypotenuse. The opposite side to theta is over here, that's A, and the hypotenuse of this right triangle would always be across from the right angle, that is C. All right, if we want to look at the cosine of theta, And let me make sure you understand that you would never see the word cosine just sitting there by itself. You have to talk about an angle because you don't know which side is opposite or which side is adjacent or which side is what unless you're talking about a specific angle in the triangle. This is a function. It has to have what we call an argument. You have to be putting something into the function, and that thing is the angle. So don't ever write just plain cosine. We're talking about the cosine of something, of an angle. All right. So the cosine of this angle theta is the adjacent side. That is the side that's right next to it. So adjacent side over hypotenuse. So in this triangle, you've got theta. The side right next to theta is the adjacent side, which is B. And the hypotenuse is still C. The hypotenuse is always the longest side of the right triangle. The tangent of theta is equal to the opposite side to theta over the adjacent side. So here's theta. The opposite side, as we saw in sine, is A. It's across from theta. The adjacent side to theta is touching theta. It's B. So these are the trig functions. They have to, you can only find the trig functions in this triangle if you know which angle you're talking about. All right, so those are the trig functions for the angle theta, but what if we called this angle, say we call it angle B, capital B. And please remember in math that capital B and little b are two totally different things. They are not the same. If you use a little b for a variable and you use a capital B for a variable, they are not the same variable. So please don't use a capital letter when it should be a small letter or vice versa. So if I wanted to find the sine functions for the angle B, the sine function, I would say sine B this time, and that's going to be opposite over hypotenuse. Now the opposite side to B is little b, and the hypotenuse is still C. If I want to find the cosine of angle B, that is going to be adjacent over hypotenuse. So there's your adjacent side. That's going to be A, and your hypotenuse is still C. If you want to find the tangent of angle B, that's going to be opposite over adjacent. The opposite side to big B is little b, and the adjacent side to B is A. So you can see that you can't just talk about the trig function of the triangle. That doesn't work. You have to be talking about a specific angle so you know which side is opposite, which side is adjacent, etc. The hypotenuse, you don't really need to know an angle because it's always the same. But in order to talk about adjacent and opposite, you have to know what angle you're talking about. So please don't let me see you writing things like cosine equals or tangent equals or sine equals. There must be an angle right there next to it, okay? So take a look at this example. We want to use trig functions to find the missing parts. Round your answer to 2 decimal places. Okay, so let's say we want to find angle F. Triangle has 180 degrees total inside of it, so 90 plus 32 plus F should equal 180 degrees. So that is 122 plus F equals 180. So F is going to be 58 degrees. But I want to find it using trig functions, but it will equal the same thing. But the reason I want to do that is because you also need to know how to use your inverse trig functions. All right, so let's start out using angle 32 degrees here and find M and N. All right, let's talk about what we have and what we don't have. 32 degrees, we have the adjacent side is 5. That's the side that touches 32 degrees. So we have the adjacent side. Which trig functions involve adjacent? The cosine of an angle is equal to adjacent over hypotenuse. So we will use cosine to figure out what n is, because that's the hypotenuse. We have the adjacent, we have the angle theta, and so we can use cosine. So cosine of 32 degrees is equal to 5, the adjacent side to 32, over the hypotenuse n. All right, now n is in the denominator, and that means we need to multiply both sides of this equation by n so that we can get it out of the denominator. If we do that, we're going to have n times cosine 32 is equal to 5. All I did was multiply both sides by n. Now we can get n by itself by dividing both sides by cosine 32. The cosines will cancel over here, and we'll end up with just n. So to figure this out, you have to use your calculator. There's no way for you to figure out what the cosine of 32 degrees is just thinking about it all day. The only way to do it is to use a calculator. So you're going to take your calculator, and you will do 5 divided by cosine of 32, however your calculator does that. Usually you will have to put in 32 first and then hit cosine. After you do that, you have to hit the equal sign so that your calculator will do the division of 5 divided by cosine 32. So 5 divided by, and then hit 32 cosine, then hit equals. And you should get about 5.90. So that is n right there. Now, we want to find m. We could do that by using the Pythagorean theorem, but since we really need to practice our trig functions, I'm going to use a trig function. So again, we have the adjacent side to 32. M is the opposite side to 32. Which trig function involves opposite and adjacent? That would be tangent. Tangent theta is equal to opposite over adjacent. So let's use tangent. Tangent 32 is equal to m over 5. This time, the 5 is in the denominator, so we just need to multiply both sides by 5. And if we do that, we will have 5 tangent 32 equals m. And now we just need to punch this into our calculator. We would hit 5 times 32 tangent equals, and we would get that m is about 3.12. So we have our m and we have our n. Now we want to find f. Like I said, we already found f by just adding up all the angles in the triangle and making that equal to 180, because all triangles, the interior angles, those 3 angles, will always add up to 180 degrees. However, I want to go ahead and use one of the trig functions to find f so that you will see and make sure you know how to use inverse trig functions. So we can use any of the trig functions we want because we know all the sides now. I will just use sine because why not? So the sine of f is going to be opposite, 5 is opposite to f, over hypotenuse, which we found out was 5.90. Now, I have to use inverse sine to find f because I don't know the angle. I can't take the sine of f if I don't know f. So I can't use sine. I have to use inverse sine. That is the function you use when you know the ratio, but you don't know the angle. So I'm going to do inverse sine, that's sine with a little -1 up there, of this ratio, 5 divided by 5.90. And I am going to use my calculator. I am going to punch in 5 divided by 5.9, and then I'm going to hit equals. So that fraction has now been divided, and now I'm going to hit inverse sign. That is going to give you 57.94. And this is why, in general, I would just add up the angles in the triangle to find f, because that's going to give you the exact value. The reason we didn't get the exact value of 58 degrees is because we rounded that 5.9. Remember, it was not an exact value when we got it over here because it was some big long decimal, so we had to round it. So it didn't give us the actual value of f, but it's very, very close. All right, I want you to do this one by yourself. So turn off the video and try to do this one by yourself completely. And then you can turn the video back on and you can see how you did. Okay, let's see how it went. First of all, we could find x by using the Pythagorean theorem, and I will go ahead and do that just because I want to make sure you know how to use the Pythagorean theorem. Remember that the Pythagorean theorem says that if you add the squares of the legs of a right triangle, okay, the legs are the two sides that meet at the right angle, and the hypotenuse is the long side that is across from the right angle. If you add the squares of the legs, that's going to equal the square of the hypotenuse. So Pythagorean theorem says that 4 squared plus x squared is 6 squared. Okay? You can't just put these numbers in any order you want. The legs, the two sides that meet at the right angle, have to be on one side of the equation. The hypotenuse squared has to be on the other side. So 16 plus x squared equals 36. If you subtract 16 on both sides, you're going to have x squared equals 20. If you take the square root on both sides, the square and the square root will cancel and you'll just end up with x, and then you'll have the square root of 20. We know that we can write the square root of 20 as the square root of 4 times the square root of 5. The square root of 4 we know is 2, so that is 2 times the square root of 5. So we know that x is going to be 2 times the square root of 5, and that is the exact value of x. We know two of the sides, 4 and 6, and so we can use those two sides to find the missing angles. We know 2 square root of 5 also, but since we already have the 4 and the 6 and they're whole numbers and they're rational, we'll just use them. All right, so if we're looking at angle A, 4 is the adjacent side to angle A. It touches angle A. 6 is the hypotenuse because it is across from the right angle. So I've got adjacent to A and I've got hypotenuse. Which trig function involves adjacent and hypotenuse? That is going to be cosine. So cosine A is equal to adjacent over hypotenuse, and the adjacent side is 4 and the hypotenuse is 6. So I know that that is just 2/3. And I can now use my calculator to find A. But I can't take the cosine of A if I don't know what A is. I don't know the angle. I have to use the inverse trig function. So cosine A is 2/3. Therefore, the inverse cosine of 2/3 is A. So I don't know the angle. I use the inverse function. Inverse cosine of 2/3 is equal to A. So you're going to punch that into your calculator. You're going to hit 2 divided by 3 equals, and then you're going to hit inverse cosine. And you should get that A is about 48.19 degrees. Okay, now we want to find B. If we're looking at B, 4 is the opposite side to B, and 6 is the hypotenuse. That is sine. So I'm going to say sine of B is equal to opposite, which is 4, over hypotenuse, which is 6. And so now we have sine B equals 2/3. So we're going to use our calculator again to find B. We can't take the sine of B if we don't know what B is. So we have to use inverse sine. Inverse sine of 2/3, the ratio, is equal to the angle. I'm going to punch that into my calculator. I'm going to hit 2 divided by 3, then hit equals, and then hit inverse sine. And B should come out to be about 41.81 degrees. And if you look at the angles you have, 48.19 and 41.81 is about 90 degrees, and that's always going to be the fact. When you add the two angles in the triangle that are not the right angle, you should get 90 because all the angles in the triangle should add up to 180. And since the right angle is 90, 90 plus 90 is 180. Okay, so now I want to review how to change polar coordinates to rectangular coordinates because we're getting ready to learn how to change rectangulars to polars. So we need to do this first to make sure you remember how to do that. All right, first of all, polar coordinates is just another way of locating a point in the XY plane. And remember, the angles that we talk about in the XY plane, we start at 0 on the positive side of the x-axis, then we go counterclockwise to 90, 180, 270, and back around to 360. So we are going to locate this point, the point that is at 230 degrees, and then we're going to figure out the x and the y coordinates we would need to get to that point. So the polar coordinates, like I said, are 230. And so how do we get to 230? Again, we start at 0 degrees. We're pointing in the positive x-axis direction. And then we just start going counterclockwise around in a circle. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200, 210, 220, 230. Okay, so we have rotated around 230 degrees, and now we want to go out from the origin 7 units. So we're coming out from the origin 7. And now to figure out the rectangular coordinates for that point right there, we need to find the vertical distance from that point to the x-axis, that's the y coordinate. And then we need to find the horizontal distance from the origin to where that point would be, and that is the x coordinate. So these are the sides that we need to find. We need to find, so this side is our x coordinate, and this side is our y coordinate. So we know that the hypotenuse is 7 because that's what we have right here. And so we're going to use our trig functions to find x and y. You might be saying, wait a minute, we don't have an angle. And that's right, we do have to have an angle in order to figure out what those sides are. So what is the angle? Well, it's right here. And we know that we started at 0 and went all the way around to 230. The angle inside this triangle is not 230 degrees. That's the big angle, the obtuse angle that goes all the way around from 0 to 230. But this angle inside the triangle is just the part of that angle that is in the third quadrant from 180 to 230. So that angle right there is a 50-degree angle from 180 to 230. In other words, 230 minus 180 is 50 degrees. So the angle we're working with is 50 degrees. So we are looking for y. That is opposite to our 50-degree angle. So we're going to use sine. Sine 50 is going to equal y over 7. Opposite over hypotenuse. If we multiply both sides by 7, we're going to have 7 sine 50 is equal to y. And now we would punch that into our calculator, 7 times sine 50. So we would hit 7 times 50 sine equals. Okay, so we found our y. Now we want to find our x. So we can use cosine to find x because our angle right here, the adjacent side is x. So cosine 50 is going to equal x over 7. Multiply both sides by 7, and you get cosine 50 times 7 is equal to x. If we punch that into the calculator, okay, so if you remember, I was telling you when we learned this the first time that you need to be careful with your x and y because you have to notice what quadrant you're in. So we are in the third quadrant. This is the part of the xy plane where x is negative, you go left, and y is negative, you go down. So all the points over here in this quadrant have a negative x and a negative y. So we have to make sure we put those negative signs here in our answer so that we will be in the correct quadrant. So our y is 5.36, that goes here, and our x is 4.50, which would go here. So those are the rectangular coordinates of that point at 230 degrees. That's how you change polar coordinates to rectangular coordinates. So let's try another one. This one, we're going to change 42, 340 degrees to rectangular coordinates. So go ahead and stop the video and try this one yourself and see if you can figure that out. Okay, so 340 degrees, we're going to do it just the same way we did the last time. Starting at 0, we're going to go counterclockwise all the way around. We went to 230 last time. We're going to keep going all the way to 340. So 240, 250, 260, 270, 280, 290, 300, 310, 320, 330, 340. So that's 340 degrees. We want to find the x, the horizontal coordinate, and the y, vertical coordinate, that go to that point. We came out from the origin, 42. So 42. And remember, these drawings don't have to be to scale. You just need to label them with the values. All right. So the angle this time is right here. That's the angle between the x-axis and the radius of our polar coordinates. And we use that angle always, the angle between the radius and the x-axis. This is the right angle. And that angle there, this time, is you've gone all the way around 340. All the way around total would be 360. So this little angle here is 20 degrees. It is 360 minus 340. So that angle is 20 degrees. And we're going to use that to find our x coordinate and our y coordinate. So sine 20 is equal to opposite, which is y, over hypotenuse, which is 42. Multiply those sides by 42. Punch it into your calculator. That is about 14.36. Now we'll find x. Cosine 20 is going to be x over 42, adjacent over hypotenuse. And multiply both sides by 42. 42 cosine 20 equals x. Punch that into the calculator. That is about 39.47. And remember, now we're in the fourth quadrant. And in the fourth quadrant, x is positive and y is negative. All the points in this quadrant, you go to the right and down to get to them. So that means positive x, negative y. So positive x, negative y. So our y is 14.36 and our x is 39.47.